Hi everyone, my name is Camilo Fernandez. I am a master student of the Civil Engineering program at the University of Maine. I'm working under the guidance of Dr. Aaron Galan, Dr. Aaron Bradshaw from the University of Rhode Island, and Dr. Kit Biruk from the Department of Mechanical Engineering Technology at the University of Maine. Today, I'm going to talk about the research I have been working on, and it is on the response of modified helical piles with a collar vane subjected to overturning moment. So lightweight transportation structures, such as roadside signs, are usually supported by reinforced concrete shafts as recommended by departments of transportation across the United States. However, the construction of these elements may require different resources, and it is a time-consuming process, as illustrated in figure number 1. For single post mounted signs, DOTs often recommend shafts with diameter of 18 and 24 inches and lengths of 5.5 and 7 feet, respectively. A helical pile, on the other hand, is a highly efficient and cost-effective foundation element, and in the past it had been shown that by using a collar vane, the lateral and torsional capacity of these elements can be enhanced substantially. However, the design of roadside signs are typically governed by the wind-induced overturning moment. So in this study, we studied the response of modified helical piles with a collar vane subjected to overturning moment, and we compare its performance to those typical details that are recommended by the DOTs. Figure number 2 illustrates the installation of a modified helical pile. So it starts with the installation of a conventional helical pile, and then the shaft extension is inserted through the collar vane and coupled by using a coupling, and then the installation is resumed by applying crowd and torque, and then the collar vane is dragged into the ground, and finally the installation is complete when the collar vane is completely set into the ground and it is connected to the shaft extension or to the helical pile at the very top of the collar vane by using bolts. So to investigate the performance of the modified helical piles subjected to overturning moment, full-scale load tests were performed in a medium stiff clay in Centralia, Missouri. Helical piles were instrumented with 5 string gauge pairs distributed along the shaft in order to measure the bending strain. A moment arm, as shown in figure number 3, was used to apply a constant shear of about 6 kilonewtons, which is the highest shear acting on a single post mounted roadside sign, and a variable moment at the pile head. Instruments to measure the applied load and deformations such as load cells and string potentiometers, inclinometers, and so on, were employed as shown in figure number 3. So here I am presenting some of the results that we get from this load test. And the figure number 4 shows the pile head deflection versus the applied moment, and the open symbols represents the modified helical piles, and the solid symbols are the typical details. The colorful bands are the design overturning moment for the largest sign panel area and for different wind speeds. From this plot, it can be observed that the performance of the modified helical piles is comparable to the performance of those typical details, and most of the modified helical piles are suitable to support the highest overturning moment of design. So figure number 5 shows a typical bending moment profile on the helical pile shaft extension. So here in this plot, the different curves are for different pile head deflections or different overturning moment being applied at the pile head. So as we can observe, the bending moment on the shaft extension is considerably reduced, and this is due to the collar vane. This is due to the presence of the collar vane, and also we can observe that the shape of these curves indicates that there is no load transfer to the shaft extension in the portion embedded in the collar vane. Instead, the load transfer occurs at the very top of the collar vane, where they are both bolted together. Then the figure number 6 compares the maximum measured bending moment on the shaft to the applied overturning moment. It can be observed that the capacity of the collar vane to reduce the bending moment on the shaft increases as the collar vane size increase. So based on these results, we can draw some conclusions. So first, because of the advantages of helical piles and the easy installation of the collar vane, modified helical piles offer important practical benefits compared to typical concrete shafts. Modified helical piles with a collar vane comprise a potential alternative and solution to support roadside sign structures. And lastly, the bending moment on the shaft is effectively reduced by the collar vane, even when supporting a high overturning moment. Thank you so much for your attention.